All right, in this video, we are going to talk about different logarithmic properties. The first one that we are going to look at is if you're asked to express as a sum of logs, here's what you have. If you have log base x of y times z, that can be rewritten as the sum, which means adding the two logs together. Log base x of the first factor, which is y, plus log base x of the second factor, which is z. If you are asked to express as a product, if your logarithm, in example 2, log base x of y to the z power, you can rewrite that as a product, which means I'm actually going to bring that z down and make it times the logarithm. Expressing as a difference, if you have log of x over y, and you need to express as a difference, which means subtraction, you are going to have log of the numerator minus log of the denominator. And the last property that we're going to look at is if these two things are the same value, log base b of b, the answer to that is 1. That's always going to be 1 if those two things are the same. So we are going to use these properties to work some problems. Example, log base 19 of 19 times 361. It wants me to express this as a sum of logarithms since it's being multiplied. Looking at rule number 1, that's how you would express that as the sum of those logarithms. You're going to have log base 19 of the first factor, which is 19, plus log base 19 of the second factor, which is 361. Another example, ln of y times z, and we are going to express this as a sum of logarithms using rule number 1 again. So since these are being multiplied, I can rewrite that as the sum of the logs, which will be ln of the first factor, which is y, plus ln of the second factor, which is z. All right, in this next example, we have log base n of s to the 12th, and it's asking us to express this as a product. So this is talking about rule number 2. If your log is being raised to an exponent, you can rewrite that as a product by bringing that exponent down and making it times your logarithm. So 12 times log base n of s. Right, in this example, again, it's telling me to express this as a product. So I am using rule number 2 again. However, I don't see the exponent as it is written now. Let's remember that if you have the 5th root, that is the same thing as raising what is underneath that radical symbol to the 1/5 power. So this is the same thing as saying ln of 7 to the 1/5 power. So 5th root and 1/5 power are the same thing. And now I can use rule number 2 and rewrite it as a product by bringing down that exponent. So I have got 1/5 times ln of 7. All right, on this next example, it tells me to express this as a difference. So we are using rule number 3. So if I have log base b of b over 10, and I want to express this as a difference, I will have log base b of the numerator, which is capital B, minus log base b of the denominator, which is 10. Right? Another example of expressing as a difference. So rule number 3, again, I've got ln of s over w, and I'm asked to express this as a difference of logs, which would be ln of the numerator, which is s, minus ln of the denominator, which is w. Right? On this next example, it's going to say rewrite as sums or differences of logarithms. Remember, if you have factors, which means being multiplied together, those are rule number 1, rewriting as the sum. So I will have ln of x to the 6th plus ln of the next factor, which is y, to the 7th, plus ln of that last factor, which is z. Now, you don't want to leave these with exponents. Remember where the exponents can come. Those can be rewritten as times the logarithm, or rewritten as the product. So I will have 6 times ln of x plus, bringing down that exponent of 7, times ln of y plus ln of z. All right, on this next example, I've got log base b of p to the 3rd, q to the 6th, over m to the 5th, b to the 9th. I'm actually going to use a combination of expressing as sums and differences because I have factors and I have quotients because I have that fraction bar. So it's going to start off with log base b of the first factor in the numerator, which is p to the 3rd. Since I'm staying in the numerator, this is going to be a sum of log base b of that second factor, which is q to the 6th. Now, since I am moving to the bottom of that fraction bar, this is where you turn into differences or minus. So minus log base b of m to the 5th and minus log base b of b to the 9th. And just like that last example, I want to bring down these exponents. So I've got 3 times log base b of p plus, bring down the 6 times log base b of q minus, bring down that 5 times log base b of m, and then I have minus, when I bring down this 9, and it's times log base b of b. Remember what that 4th rule was on the logarithm properties. If these are the same, base b of b, this whole thing right here turns into 1. So I actually have minus 9 times 1 there, which is just minus 9. So that's why this is the answer, because this last log base b of b turned to 1. Right, this next one, same kind of thing. I've got sums and differences. because I have a fraction. So my first one will be ln of 8. That's the only one in the numerator. So since I am moving now to the denominator of this fraction bar, I'm going to switch to differences, which is minus ln of 7 minus ln of x to the 7th minus ln of y. And last step, bring down that exponent. So I've got ln of 8 minus ln of 7 minus 7 ln of x minus ln of y.